Hello all, in today's problem we're going to be using the property tables to draw a PV diagram and find the state at which our specified location is at. We are given a P of equal to 1000 kPa and a specific volume of 0.1 meters cubed over kgs. We are also asked to find the enthalpy, which is denoted as U plus PV. First, we'll start off by drawing our PV diagram, and then we'll label our 1000 kPa on the p-axis. We're later going to use this 1000 to find the specific volume of fluid and specific volume of vapor from the water tables that are given. Now that we have everything drawn out, we'll move to our charts. We have the saturated water tables. We were given a pressure, so we're going to look for the chart that uses the pressure of 1000. Here I've already labeled it out for us, so we're going to use that. We can see that the saturated liquid for the fluid is given by 0.00127. So we're going to move to our drawing and go ahead and label that on there. Similarly, we're going to go ahead and find our specific volume for saturated vapor, which is given next to it at 0.19436. So we're going to go ahead and label that on our specific volume axis. Since we can see that our specific volume of 0.1 is between the saturated vapor and the saturated gas, we now know that we're in the saturated liquid vapor mixture region. If it was greater than the Vg, we would be in the superheated, and if it were less than the Vf, we would be in the compressed liquid region. So here I am just labeling out so that y'all can see this verbally. We were also asked to go ahead and put our temperature line from all the regions, so here I am drawing it out. We can see that on a PV the temperature line goes downwards, and this is given from the charts at 179.88 Celsius. Everything's looking great at this point. Lastly, we were asked to find the enthalpy, which again denoted by U plus PV. So now in this portion we're going to go ahead and solve for that. As you can see, H includes U, and we're not knowing that. U is denoted by UF plus X UFG, where X is the quality. And so X is given by V minus VF over VFG. So we're going to use our V of 0.1 minus the specific volume of fluid, which is 0.00127. VFG is just VG minus VF. So we're doing 0.19436 minus 0.00127, and we'll get an X equal to, X is equal to 0.511677612. That's the mass ratio of the vapor over the total mass. Now that we have X, we're going to go ahead and solve for U. Using UF, that's from the charts, and UFG is also from the charts. So we'll go ahead and plug and play. We'll find that U is equal to 1693.359602. Now we can plug that into our H equation. So U plus PV, and we'll see that H is equal to 1793.359602 kilojoules over kgs. Thank you. Have a great day.